This is the deepest canyon on Earth. Over a span of just 50 kilometers, the river below drops 2,000 vertical meters. To understand the scale of what China is building in this chasm, look at the Three Gorges Dam. It currently generates 22 gigawatts of power. The Medog Megadam is designed to generate 60. It nearly triples the output of the world's largest dam. The geography making this possible is a sharp curve known as the Great Bend of the Yarlung Sangpo. By cutting straight across this mountainous loop, engineers can capture the full kinetic energy of that massive 2-kilometer drop in one concentrated location. This animated map tracks the river's flow out of the Himalayas. Once it crosses the border into India, it becomes the Brahmaputra, and later the Jamuna in Bangladesh. 300 million people rely directly on this water system for their survival. China controls the source water, and currently no international treaties exist to govern its distribution. As a result, the physical capacity to regulate the flow into India and Bangladesh rests entirely with the operator of the dam. Just reaching this site requires a massive logistical effort. The region is separated from the Chinese road network by hundreds of kilometers of mountain terrain and sits directly on an active seismic fault line. Before heavy machinery could arrive, work crews spent 4 months blasting 12 kilometers of access roads directly into sheer granite cliffs. For everything that couldn't wait for a road, they used heavy-lift helicopters to drop precision parts and emergency gear directly into the gorge. To move workers across the canyon, they strung a massive cable car system from rim to rim. What would normally be a 3-hour drive along treacherous cliff edges is reduced to an 8-minute ride through the air. The target they are trying to tame is incredibly violent. During the monsoon season, the Yarlung Sangpo blasts through this narrow gorge at 14,000 cubic meters per second. It costs billions of dollars simply to set up the logistics network. Long before a single batch of concrete is poured, an entirely new highway, power grid, and supply chain had to be forced into the mountains just to make construction possible. You cannot build a dam in a flowing river. To dry the riverbed, engineers have to route the water around the site by boring 4 individual tunnels, each 20 kilometers long, straight through the solid mountain. This 3D schematic shows Namchik, Asia's largest tunnel boring machine. Weighing 4,000 tons, it was assembled directly in the canyon. At the front, 240 tungsten carbide cutters rotate under extreme pressure, physically fracturing solid granite as the rig pushes forward. At 8 kilometers deep, the rock is heavily fractured, and groundwater forces its way into the tunnel. Crews inject high-pressure liquid cement. Within 48 hours, the liquid cement hardens inside the rock face, sealing the mountain so the machine can safely bore through. It takes 4 of these machines running 24 hours a day for 51 months to punch through to the other side. Each tunnel requires the precise removal of 50,000 cubic meters of Himalayan rock. Once hollowed out, the tunnels are lined with thick steel penstocks and wired with thousands of seismic sensors. Engineers have built a massive, earthquake-detecting bypass artery designed to swallow an entire river. With the bypass tunnels finished, explosives rip open the canyon wall, giving the water a new temporary path of least resistance. Simultaneously, dump trucks pile rock and a thick clay core across the main river. This is the upstream cofferdam. It costs hundreds of millions of dollars to build, and its only purpose is to block the natural flow before it gets demolished later. The original riverbed runs dry. For the first time, workers can stand on the canyon floor to scrub loose fragments from the exposed bedrock, ensuring the dam foundation sits on a clean surface. This cross-section shows roller-compacted concrete. Dump trucks place the concrete mix in 300-millimeter layers, which are immediately crushed flat by vibratory rollers. Cooling pipes run constantly through the rising structure to prevent extreme temperatures from cracking the fast-setting concrete. This exact process is repeated simultaneously across 5 separate construction sites, over 50 kilometers. Together, these 5 cascade dams form a continuous staircase, structurally capturing the full energy of the 2,000-meter drop. At the base of each cascade sits a massive powerhouse. Across all 5 stations, engineers are installing a total of 60 individual turbine units, each rated to generate 1,000 megawatts of electricity. The water is guided into these turbines by 300-ton steel spiral casings, but there are no foundries in the Himalayas. These heavy components are cast thousands of miles away in the industrial shipyards of eastern China. From Shanghai, the parts begin an 18-week journey. They travel by heavy rail to Lhasa before being loaded onto specialized road freighters for the final 500-kilometer crawl through arid valleys and winding mountain passes. Once on site, overhead cranes carefully lower the 280-ton Francis turbine runners down into their designated concrete pits. The installation requires microscopic precision. If a runner is misaligned by even a few hundredths of a millimeter, the imbalance will cause the machine to physically tear itself apart within hours at operating speed. The complex is an interconnected 60-part machine, where industrial-scale concrete meets sub-millimeter calibration, all operating in the center of the world's deepest canyon. When the water finally drops to the penstocks, it hits the runners, spinning massive rotors inside the generator stators above. That magnetic induction produces 12,000 megawatts of electricity inside a single powerhouse hall. Every generator is wired into a centralized control room. A single operator at a desk can monitor and throttle all 60 turbines across the entire 50-kilometer cascade simultaneously. The electricity is stepped up to 800 kilovolts and sent out along 4,000 kilometers of ultra-high voltage transmission lines. In milliseconds, the raw gravity of a Tibetan canyon is converted into grid power for eastern China. After shedding its energy, the water is channeled through tail race tunnels back into the original riverbed. China points out that they are only borrowing the elevation drop, not consuming the actual volume of water. Officials in New Delhi are watching closely. Indian External Affairs Minister S. Jai Shankar has raised the issue directly at international summits, as India is forced to aggressively monitor every fluctuation in the river's flow. The stakes are entirely human. Any sudden release or restriction of this water travels downstream, directly impacting 30 million people in the Indian state of Assam alone, before continuing its path into Bangladesh. This aerial view highlights the sprawling sandbars of the downstream basin. Just 25 kilometers from the massive turbines, the river crosses an invisible border into a country that had absolutely no say in the dam's construction. By 2033, this $167 billion complex will provide zero-carbon energy to 300 million Chinese homes. But in doing so, every megawatt generated upstream becomes a unilateral river management decision, imposed on 300 million people downstream who were never in the room.